Welcome to Ask and Learn.
Okay, so this man would like to consume an extra order of French fries at lunch, and he's hoping if he does a little bit extra exercise, it will compensate for the calories in those fries. Um, this type of question always makes me a little sad because, well, we'll see in the end here. But there's also some other things to take into account beyond just the potential energy change. But for this problem, we are just concerned with the potential energy change. So the change of, let me rewrite that there. The change in potential energy in this scenario is going to be equal to his mass times the height that he raises that mass against the force of gravity. And of course, mass we are going to have in kilograms. Height is going to be in meters, and gravity is going to be in meters per second squared. What this does for us is it will give us an answer in joules, because joules are equal to kilograms times meters squared per second squared. All right, so kilograms from the mass, meters squared from the height and the gravity, divided by seconds squared from the gravity. So when we do get this answer, it will be in joules. So let's figure out each of these first and then multiply them together. So first of all, the man's mass. He is 201 pounds. And although weight and mass are not the same thing when we are here on our planet under normal gravity, there is a conversion we can use where 1 pound is 0.454 kilograms. This gives the man a mass of 91.3 kilograms. All right, so we have a mass. Let's figure out the height. So it says that he is going up 3 flights of stairs, which are going to be 45 feet and 20 times. And we need this in meters, so I am going to add the conversion factor here. There are 3.28 feet in 1 meter. So in terms of meters, this gives us a total of 274 meters is how much he is going up. And then finally, of course, gravity. That's just a constant, 9.81 meters per second per second. All right, so meters per second squared. So we have everything we need here to plug into our equation. So the potential energy that he is going to release from his body by moving it up that distance against gravity is going to be his mass, which was 91.3 kilograms, times the height, 274 meters, times gravity, 9.81 meters per second squared. And we said that these units would end up giving us joules. So calculating this looks promising right now because I got 245,409 joules. Woohoo, that sounds like a lot of energy that he's going to expound. But let's get that into calories so we can compare that to the French fries, which were 245 calories. So let's see. There are 4.184 joules in every lowercase c calorie. Lowercase c calorie is the amount of energy to raise 1 gram of water 1 degree Celsius. However, that is not dietary calories. Dietary calories are actually kilocalories. There are 1,000 of the lowercase calories in 1 kilocalorie, or 1 dietary calorie, which in chemistry is written with a capital C to differentiate it from the other calorie. Somewhere along the way in dietary terms, they lost the kilo on calorie. But the calories printed on food are actually kilocalories. So let's go ahead and do this math and see how many calories this guy's burning. We have a whopping 58.7 calories. As I said, this is always a little depressing to me to look at exercise in this manner, but there are, of course, lots of other benefits. So that is, this is only part of the picture. But in direct calories, just moving his mass up that height, this is the amount of energy that will be expended. If you remember, those fries that he wanted for lunch are 245 calories with a capital C. So 58.7 is considerably less than 245. So he is incorrect. He is not correct. He's incorrect because the exercise will not burn that many calories. While being good for him, it will not burn that many calories. Not as many as the French fries anyway. So good intentions, but food and exercise don't typically trade off so directly like that. All right. Thanks so much for watching.